I'm going to be telling you the most important things you need to know about solar energy. There are four main ways that we harness the solar resource. A lot of times people think solar energy and they immediately go to solar PV. And for electricity production, that is the biggest and fastest growing part of utilizing the solar resource. But there's actually a lot of ways that we use our solar resource. One, which is not directly measured, is just indirect light. We use our solar resources to provide light in our buildings, when we're outside. We do activities during our day when there's daylight. We get a very big energy service from our solar resource just in providing light. And then in the energy industry, we kind of talk about these three different buckets utilizing the solar resource. One is direct hot water heating. Typically, those are lower temperature, like hot water we would use for showers or those kind of things, not typically high heat like we might use in some industrial processes. There's some investigation there, but you can kind of get a sense that we are using the solar resource for hot water heating. Then our big category, which we're going to mostly focus on, is our solar PV. That's our biggest part of the energy system that we're using our solar resource for. So that's providing electricity. And then a very small portion for solar thermal power. And so that's also providing electricity, but we're using the solar resource to provide heat to run a thermal power plant. You can see it's a much smaller scale, much smaller portion of our mix. So really, how big is the solar resource? And the answer is huge. And a lot of our energy resources on the renewable side are powered by our solar energy, as were our fossil fuels. Because if you think about it, those are just ancient biomass. And that energy came from the sun. So the sun is the main energy resource for much of our resources. We have a lot of solar energy. So here I'm just showing you the solar resource that's hitting our planet compared to the world energy consumption now and in the future. So the resource itself is big. And it's also available pretty much anywhere people live. So that solar resource is actually very good across different populations across the world. It's not just in places where you think about like a desert or something like that. We actually have good solar resources all over the world. And, in this picture, all over the United States, a very, very high quality solar resource. And today it's providing about 7% of our electricity generation, both in the world and the United States. And that solar resource is growing rapidly. And we see that growth and compare it to other energy resources. Solar photovoltaics in particular are growing much faster than our other resources. Now, recognizing that's coming from a smaller starting place, but the growth is been like this for about a decade, where it's really been growing very rapidly as costs have come down and have really driven this as one of the leading ways to provide electricity for new electricity or new expansion electricity. In the United States, most of that PV growth has been in large scale, or what we often call utility scale solar, and we'll talk about why. But we've also have, about 30% or about a third of our solar electricity generated by small scale. So that was for our residential and commercial scale, what you see on tops of parking lots, things like that, smaller scale resource. China is leading the way in solar electricity generation and growth in solar PV installation, as they are leading the way in a lot of other types of electricity generation. And so you can see the dramatic growth we've really seen in electricity generation. So this is actually the electricity they're getting from the solar capacity they've installed. You see this major growth in the United States, and then you see growth in some other countries, including the rest of the world. So solar being this low cost, relatively easy to install resource for electricity generation has really led to this growth. So I mentioned that those costs have fallen dramatically. This is just showing you in a graph where our costs were, just a decade and a half ago. Much, much higher costs per megawatt hour that you would get out of solar. And those costs have come down through science on the module side, through scaling of our manufacturing of solar, and just through the demand and the economics of our solar. So what does that look like in terms of comparing it to other resources? The way we compare a lot of our resources is through something that's called the levelized cost of energy. What that means is we're levelizing the cost because some of our resources are very capital intensive, but don't have much in terms of fuel or operating costs over the lifetime of the project. Other projects are pretty low cost up front, but then they have fuel and maintenance costs over time. So levelizing that puts them on somewhat of a level playing field for the costs of those resources. And you can see our solar, especially our utility scale solar, is one of our least cost resources for electricity. These numbers, you see the huge range. These are based on actual projects per amount of electricity they will produce over the lifetime of the project. So you can see the difference when we see utility scale, commercial scale, residential scale. You get a very different cost curve in terms of your solar. And a lot of that has to do with the productivity of your solar panels, depending on which place you're putting it and the economies of scale. You get a lot of economy scales at utility scale versus very customized resources. I want to emphasize that cost is just one thing you think about when you are thinking about what you're going to install for your electricity resource. There's also other things that you have to consider. It's not just the cost of that resource. So solar provides other value on time, summertime peak resource when it's pretty valuable electricity. You don't have fuel price risk because you don't have to pay for the fuel for solar. It can be very predictable, and that predictability is becoming more and more predictable. Our modeling has gotten a lot better. We have no carbon, low environmental impact. These are all things that are other values for solar. But I want to also say there are other costs that aren't integrated into this, which can include the cost of integrating that solar into the grid. And so as we integrate solar into the grid, we actually see other resources increasing their costs to help with that integration. And so this is not a complete picture of what's happening. So one of the ways that we are improving our solar production and reducing costs is improving the efficiency of our solar PV. So part of that cost reduction curve we saw is because we've gotten so much more efficient. This is a lot going on this chart, but it is amazing. And you can go and look at this in more detail, but we have a lot of different types of technologies. We have single cell, multi-cell, crystalline, thin film. These are all different technologies, and the efficiency of all of them have been increasing over time. Your costs will come down because you're generating more electricity per the amount of solar panels that you're putting on the ground. There are other ways that we increase the productivity and reduce costs, especially for utility scale solar. So one of the ways that we do that is something called tracking systems. And so something like a single axis tracker, which is the most common way tracking system we use for solar PV, that just allows the solar to move with the sun. So in the morning, it would be facing the east, and by the evening, it would be facing the west. You can gather a lot more of that solar electricity on your solar panel and really increase your productivity. You can do it even more with dual axis trackers. These aren't done as much because the gains that you get aren't really worth the extra complexity and maintenance required for that dual axis tracker. So that single axis tracker does not only get you more solar production, but it also extends the times into the morning and evening where we really value more of that electricity production. Other ways that we're increasing efficiency in a very new way is something called bifacial solar panels. So one of the great things about solar panels is that they can take advantage of not just direct light that's hitting the solar panel, but diffuse light. So you actually are producing electricity on a cloudy day as long as there's some sunlight coming through the clouds. It could be sunlight that's reflected off of something else and hits your solar panel. It does not have to be direct sunlight. And so bifacial solar panels actually are able to make electricity from solar on both the front side and the back side of the solar panel. And we see increases of efficiency of 10 or 15%. So this is really starting to dominate our solar cell market share. And we think it'll continue to dominate, especially at utility scale, where you can actually have solar bouncing off the ground and hitting your solar panel from underneath. So with the cost reductions, with the efficiency, with the lowest cost resource, we're really seeing the solar resource be a significant portion of electricity capacity additions. This is just showing you for the United States, but we're seeing it in other countries as well. And that is expected to continue, especially at the utility scale, which is really where we see those lowest costs are at the utility scale solar PV. So I mentioned that cost isn't everything. And so one of the challenges with our solar resource, as we put more and more solar on the grid, our solar resource is only available to us during the daytime. And what we see is an increase in ramping needs in order to meet demand on the grid. In the morning, when the solar is coming up, you have to ramp other resources down. And in the evening, when the solar is going offline, you have to ramp other resources in the evening. So it's low cost, but you do have other challenges that you need to work with. The way that we manage those challenges, things like storage, adds that flexibility that we need on a day-to-day basis. You can also have regional integration so that you have more solar sites stretched over a larger resource. And there's a lot of tools to help with integration, but it is an additional part of the solar story that needs to be managed on the grid. So photovoltaics, which is this biggest part of the solar resource, how it works, you've probably heard about it a little bit. I'm not going to go into a whole lot of detail here. We have a great short video on our website on how photovoltaics work. So we create a solar cell, we put those together into a larger system that's a module, and then the modules together form our solar array. We use a lot of different semiconductors. The primary one is monosilicon, but there are other resources that are being investigated. And you can see thin film is kind of the next biggest category for our solar PV. Where we make our solar PV is pretty much in China. Those are where most of the manufacturing is done. It used to be more in Germany and Japan, but China really now dominates the solar PV production. So let's talk a little bit about the pros and cons. So great things about solar: no water, no emissions. They're very modular. You can co-use it for land, so you can put it on buildings, you can put it on parking lots. You can even do agrivoltaics, which are, so you can even do it with farming or other things along with the solar panels. These are all advantages of solar. Some of the challenges: the manufacturing can use a lot of hazardous wastes or materials. We don't do a lot in terms of recycling with our solar panels, so end of life can be a challenge. A lot of that just goes to landfill. And then we do have a large land use, especially at utility scale. So we do have impacts on the landscape, on our deserts or our green fields with our solar installations. So those are challenges that need to be managed. We do a lot of off-grid and rural electrification, so solar is great for this modularity, where we can use it in a lot of different applications for our solar. And we have a lot of emerging technologies that are coming, like photovoltaics, where we're putting them on tops of water or putting them over canals and aqueducts to not only produce electricity, but reduce the evaporation from our solar. And of course, we're constantly doing more with building integrated solar or thinking about dual use of land with our solar resources. Finally, I just want to say that the growth in solar that we've seen has been way more than was ever predicted, and we kind of predict it every year. So solar is expected to continue to grow, likely faster than predictions. If you want to dive in more, please check out our full lecture on our website. And of course, check out our Energy Spotlight